Okay, today we're going to take a look at solving equations. So let's look at the first equation. So some of you are probably like, man, this is easy because what do I add to 3 to get 19? Well, that's exactly the thinking that you should be going through, or the process you should be going through every time you take a look at these equations. But how do we algebraically solve it? Well, we want to get rid of what's being added to the variable or subtracted to the variable first. So that's your first step of attack each time. So right now I'm adding 3. How do I get rid of positive 3? Well, I would add to it negative 3. And because I'm doing that to the left-hand side of the equal sign, I also need to do that to the right-hand side of the equal sign. So that gives me x, and then positive 3 and negative 3 gives me 0. Then I have my equal sign that I bring down. And 19 minus 3 gives me 16. 16 is the solution to this equation, and I showed the algebraic way of solving it. So now let's take a look at this example. All right, so locate your variable. In this case, our variable is x. And then locate if anything's being added or subtracted to that variable. So in this equation, we're adding 26. So how do I get just x on that side of the equation? I need to get rid of positive 26. The way of doing that is to take away 26. If I'm doing that on the right-hand side of this equal sign, the right-hand side, I also need to do it on the left-hand side. I need to take 26 away. So what do I have left? I have 26 minus 26 gives me 0. And then I'm going to bring down the x. And then I have 11 minus 26. So hopefully you were like, 11 minus 26, that gives me 15. So my answer is 15 equals x. All right, so this example has no addition, has no subtraction, but it does have an operation being done. The 6 and the x are next to each other, which means there's an invisible multiplication. What is the opposite of multiplying? It is dividing. So I'm going to divide both sides by 6. When I do that, 18 divided by 6 gives me 3, and 6 divided by 6 gives me the giant 1, and 1 times x gives me x. So my answer is x equals 3. All right, next example. This time we have a couple different steps to do, and if we take a look at it, our variable's right here, and we have 7 being added to it. So we need to reverse that 7. So we're going to subtract it. And that's going to leave me with the 2x, because I didn't change it, so I'm copying it down. And then 7 and negative 7 gives me 0. And 15 minus 7 is 8. So now I need to decide what operation to do next. I have 2 times x, so the opposite is to divide. And when I do that, I get 2 divided by 2 is 1, and 8 divided by 2 is 4. So my answer is x equals 4. All right, let's try another example together. This one's a little different than the ones in the previous slides because I have a negative 4, or I'm subtracting 4 from x. So how do I get rid of it? I need to add 4. And it doesn't look like an equal sign, so I'm going to make that look like an equal sign. So what do I have left? Well, I didn't change the 4x, so I'm going to copy that down. And negative 4 and positive 4 gives me 0. I'm going to bring the equal sign down, and 32 minus 4 is 28. So my next step is that this is 4 times x, so the opposite is to divide by 4. And I'm left with x equals 7. Let's do a couple more examples. All right, so here's the next example. Please copy it down on your paper, pause the video, and check back in. All right, where did you get stuck? Well, it's subtracting 2, so the opposite is to add 2. And then what I have left is 3x equals 9. This is 3 times x, so I'm going to divide by 3. And what I'm left with is x equals 3. All right, practice on your paper.